Okay, another optimization problem. A geometry student wants to draw a rectangle inscribed in a semicircle with radius 6. If one side must be on the semicircle's diameter, what is the area of the largest rectangle that the student could draw? So what it's saying is that the rectangle sits, just like drawn here, sits on the diameter of the semicircle. Doesn't say that it's the full length of the diameter, it just means the rectangle sits on it. And it does tell us that the radius of the semicircle is 6. So I'm going to put that there and I'm going to go ahead and label it. And I'll go ahead and put 6 units because it doesn't tell us. Okay, so if what is the area of the largest rectangle? Well, what are the things that we know? We know that the area of a rectangle is length times width. We know that from, I don't know, 5th, 6th grade math. And probably from 6th, 7th, 8th grade math. We know that, okay, here's the hypotenuse. Here is the length of a rectangle, but half of that length of the rectangle, half of that is part of this right triangle that is formed in the inscribed rectangle. Remember, rectangles, all 4 corners are right. So now we have a right triangle. I'm going to name this side X. And if this side is X, this side is X. So the full length of the rectangle, the length is equal to 2x. So we just don't know this side. Well, if we have a right triangle, we know that x squared plus question mark squared equals 6 squared. And in reverse, we know that 6 squared subtract x squared is going to equal that third side squared. And to find the third side, we would take the square root of both sides. So let's see if I even put that. Now, I just gave you, so what we do know for sure, and I put inches, but really I should have just put units because it doesn't tell us inches. Radius is 6, and we know the formula for a rectangle since that's what we're dealing with. And I'm going to go ahead and we can derive this other stuff by the information that's given. But what we want to find is, what is the areas of the largest rectangle that the student can draw? So what we're trying to do is we're maximizing. So remember in all that curve sketching that you've been doing where you're trying to find maximas and minimas, and you do that when you find the derivative of a function, set it equal to 0, and the x values are possible maximas or minimas. Well, that's what we're doing here. On optimization problems, we're using derivatives to find maximas or minimas. In this case, it would be a maxima. So we're going to take all this. So let's see what we know. If we know that the area is length times width, and we know that this width, this entire width is 2x. So area is equal to 2x. And what did we decide that this side equals? Well, the question mark, when you take the square root of question mark squared, it's the square root of 6 squared subtract x squared. So now we have this full length times this width, and then when you multiply that out and get the function, take the derivative of that function, and you will then we'll be able to set the derivative equal to 0. So, and I did most of the work on the next page, but I'm going to rewrite this right here as 6 squared minus x squared to the 1/2. And I'm probably actually going to rewrite 6 squared as 36. Okay, so on the second page, that's what I did, rewrote it, and now we're going to take the derivative. So dA dx, or a prime you could have written. So now we're just going to use the product rule. Here's the f of x, and this whole thing is the g of x. So it's 2x times the derivative of this, which is 1/2 times 36 subtract x squared. Now to the negative, 1/2 subtract 2 over 2 is negative 1/2, and then you take the derivative of inside the parentheses, which would be negative 2x. Remember, and then the product rule says then you add this times the derivative of this. So 6 squared is 36. 36 subtract x squared, all of that to the 1/2. The derivative of 2x is 2. And now the next step, all I'm going to do is simplify, and I'm probably in the next step going to pull out what they have in common. So when I do that, they both share it. Whoops, that's too big. They both share a 2. They both share this thing, and the smallest one is the negative 1/2. So we're going to pull out a 2, and then this quantity. And when you pull out this 1 to the negative 1/2, well, think about the laws of exponent. If you have x to the 1/2 divided by x to the negative 1/2, you rewrite it as x to the 1/2, subtract that exponent, which is negative 1/2, which is plus. 1/2 plus 1/2 is just x to the first. And then x to the first is 36. 36 minus x squared. And then I simplified. When I pulled this out, that left 1/2 times negative 2x, which would be negative x, times x, is that negative x squared. This whole thing right here, remember, goes down to the denominator because it's that negative exponent. And then we're going to multiply. We're just going to do the distributive. We're going to combine those two things first before we do the distributive. And when we simplify, inside here, we'd have negative 2x squared plus 36. When you multiply 2 by each of those, you get negative 4x squared plus 72 all over that quantity now to the positive 1/2. And then we set the left side, the derivative equal to 0. And all I did in the numerator is factor out a negative 4. Remember, if I factor out a negative, a positive divided by negative inside here will now be a negative. And then all we have to do is set this thing equal to 0. So if you do x squared, if you subtract 18 is equal to 0, and you add 18 to both sides, x will equal x squared. You take the square root of both sides. Well, square root of 18 is the same as 9 times 2. The square root of 9 is 3. And remember, there's a positive and negative version, but because we're dealing with a measurement, it's always going to be the positive. So x is equal to 3 root 2. So this is 3 root 2, and this is also 3 root 2. So two of them together, 3 root 2 plus 3 root 2 is 6 root 2. So now for the rectangle, the length right here is 6 root 2. And we just can simplify this. 6 squared, subtract, we know what x is now, 3 root 2 squared. When you simplify that, the question mark is also 3 root 2. So this is 3 root 2 also. And then when you multiply 6 root 2 times 3 root 2 to find the area you'll find is 36 inches squared. So that was a lot to think about, a lot to set up. Optimization problems are not difficult once you get a handle on setting problems up and thinking about formulas and learning how to set the variables correctly. All right, that's it for this one.